In this part 2 research methods basics course with Dr. T, we're taking a look at linear regression, and then we're going to move into multiple linear regression. So let's just say that we have already figured out the regression equation for the expenses that a prison company, so the expenses that a prison company pays for supplies for some kind of product that the inmates assemble and then sell. And what we are interested in figuring out is how much revenue the prison company is going to make off of one prison. Let's say they sell, all right, let's do our predicted y hat. So our y hat, let's say let's say that it's like 50.729, which is basically the slope of our line, right? This is M. And our y-intercept, oh geez, let's say it's, well, that's $50. Let's say that you're just a little more than double, so $104. Okay, so this is B. All right, now if I were to say a specific prison wants to add an extra $1,500 to what they're spending in supplies, how much money then could we predict that they're going to make from basically the prisoner's labor, right? And we've done all the calculations to figure out the difference between, what the prisoners get paid, like 10 cents an hour, to what we've put in. And this is our regression line equation here. And they're going to spend $1,500 more. What are they going to essentially make after they add that $1,500 to things, right? So what we do is essentially we're just going to plug in the line, the regression equation, right, to see how things change. So if we do that, then we'll have y hat is going to equal that 50.729. And I said it was going to be another 1,500, right? Times 1,500 plus that kind of initial, that's what they were making here, 104.061. That's our starting point. That's our y-intercept, right? Well, after they add that $1,500, we can predict that their revenue will then be, do all the math, 180.155. Not bad, right? There's the prediction that we can make. Now, we're really interested in making sure, though, that all this error that we have up in this tiny line up here on the right between the observed and the predicted, isn't so great that we're just making stuff up. So we want to be able to calculate the standard error of our estimate, okay? So the standard error of the estimate is noted as a lowercase s with a subscript e. And the equation for that, it should kind of look familiar. It's the square root, the sum of all y, I'm going to use an I, minus y bar I squared divided by n minus 2. So if we're thinking about and freaking out a little bit about what is this yi thing, well, remember, for every x value, there's a corresponding, I don't know how to really do that, there's a corresponding y value, right? Because, if we're looking at the crime rate, which would be our dependent variable and the percent poverty in a city, which would be our independent variable, then for every single city, we're going to have percent poverty, and that city will have its own crime rate, right? So yi is just the y value for the given x value. And if we're looking at y bar I, then that is the y value on the regression line that corresponds to a given x value. Because remember, our regression line is making a prediction, right? So we're looking, if we're looking at this standard error of our estimate, we're trying to figure out, how far off, I'm going to go back up to the right corner here, how far off our observed and predicted values are, right? We don't want to be full of it. We need to know exactly what the standard error is, and you'll see why in a minute. Till this point, we've really been only paying attention to two variables, an x variable and a y variable. But we know that's essentially a correlation coefficient, and we know there's more involved in making predictions for a dependent variable than just one independent variable, right? I mean, we listed quite a few when we were thinking about what might influence changes in crime. So that's where this multiple regression equation comes in handy. So we have this kind of correlation, this bivariate, just two variable regression going on. But now let's see what we can do when we add more, right? So the multiple regression equation is what allows us to add in all of these control variables, essentially holding them at the same level, right? And only our independent variable is really changing, the one we're most interested in, so that we know whether or not that independent variable is statistically significantly related to the changes in our dependent variable. So here's our multiple regression equation. Multiple regression. We're using multiple variables. And this is where I think it gets kind of fun and kind of cool. So once we have kind of the basics of a linear regression equation, now we can do y hat equals b plus the slope of kind of the first regression that we run between just an independent and our dependent variable. So it's going to be m1 and x1 plus m2 x2. And we can go on like that forever. m3 x3. And we'll just do it all the way. We'll just say to, I don't know, m whatever number we stop at, we'll make it k to xk. And then we can't forget that there is error, right? So we'll put error in there. And that is why this piece is so important, because we can't really observe how much error we have, right? We have to estimate that. And so that gets included in the multiple regression equation. Now, aren't you thankful that there is software like SPSS? Actually, Excel can do this too, that can calculate all of these pieces for you without you having to make a huge, gigantic table for thousands and thousands of cases just to make a prediction. Stay tuned. I'll talk you through the output of a linear regression.